Let's start out by defining the categories of chemical reactions. The 6 that I want you to know are combustion reactions and be able to identify them, and also synthesis or combination reactions, and decomposition, breaking down, so decomposition reactions. There's precipitation reactions, which is also has a double displacement. And then there's acid-base, which is also a double displacement reaction. And the last one is a mechanism one, but it's single displacement reaction. And then I'll talk about how you can identify them in a formula. The way you identify combustion reactions is that you have a reactant that is combining or reacting with oxygen. O2 will always be on the reactant side, and you will make something that combines with oxygen, sometimes more than one thing that combines with oxygen, but they will both end up combining with oxygen. Synthesis is when you have sometimes elements, and the two elements will end up combining together to make a compound. So the key is there's only one product. The opposite of that is when you have one reactant and it ends up breaking down into elements or its parts, sometimes compounds. This is, you can identify these because there's only one reactant in a decomposition reaction. In a precipitation reaction, it's not as important to know what the chemicals are. What you look at is the states of matter. If you have two aqueous solutions that ends up making something that's a solid and a liquid, or not a liquid, I'm sorry, aqueous, AQ, then that's a precipitation reaction. And you can figure out the products because it's got a double displacement mechanism. How you classify an acid-base reaction is it has one compound that begins with H, and there's usually another compound that ends with OH, and it ends up making water and something else. Single displacement usually has an element and a compound, and what happens is that the element ends up replacing one of the other elements in the compound and displacing it, and that element ends up sticking with the other element in the compound. So let's apply these definitions to the examples on the left. The key thing that I want you to look at on this first example is that it has an OH and H in front here. The OH tells us that this is a base and this is an acid. So this is an acid-base reaction for the first one. So the second one, the key thing to look at is that it reacts with O2. This one is a combustion. And then on number 51, we have two aqueous solutions end up making an aqueous, and the key part of this is it ends up making a solid. So this one is a precipitation. reaction. And products are made by double displacement. 52, you have an element reacting with a compound to make a new compound and a new element. So the best one that fits for this is the single displacement, where you have an element and a compound making a new element and a new compound. So this is a single displacement. And number 53, you only have one chemical on the reactant side. That's the same thing as decomposition reaction. That's an indicator that a decomposition happened. And you make multiple products. So this is a decomposition. Same thing for 54, that there's only one reactant breaking down, so this is also a decomposition. Number 55 has multiple reactants, but only one product. And so this fits the definition of a synthesis reaction or a combination. And same with number 56, it only has one product, so it's also a synthesis reaction. I've balanced these equations so you can check to see if you balanced them correctly. 49, the coefficients are 2, 3, 1, 6. 50, the coefficients are 2, 19, 12, and 14. And I'll scroll down so you can see them and check to see if you balanced them correctly.